Imagine you are standing on the shore of a cosmic ocean. You've sent a tiny bottle with a message out into the waves. For 46 years, that bottle has sent back whispers of its journey. It has traveled farther than any human-made object ever has. It is your most distant, your most tenacious explorer. Then one day the whispers stop. The messages become gibberish, a stream of nonsense. This isn't a story. This is what happened on November 14, 2023. Voyager 1, our stalwart messenger to the stars, fell silent. It was still out there, nearly 15 billion miles away, but its voice was gone. The stream of scientific data and engineering updates it had faithfully transmitted for decades turned into a garbled, repeating pattern of ones and zeros, a stuck record of digital noise. The silence was deafening for the scientists and engineers at NASA's Jet Propulsion Laboratory. Voyager 1 was more than a machine. It was a testament to human curiosity, a relic from a different era still pushing the boundaries of discovery. Losing it felt like losing a part of ourselves, a part that was bravely venturing into the great unknown. The spacecraft was so far away that a command sent from Earth, traveling at the speed of light, took nearly 22.5 hours to reach it. And the reply? Another 22.5 hours to return. Every attempt to communicate was a 45-hour waiting game, a long, slow conversation with a friend who had suddenly lost their memory. The team had to face a daunting possibility. After nearly half a century, the journey might finally be over. The problem was a complete mystery. The spacecraft's carrier signal was still strong, a steady tone broadcasting across the void. This meant Voyager 1 was still alive, still powered by its decaying plutonium source. But its brain, the Flight Data Subsystem, FDS, was broken. This system is responsible for packaging all the scientific and engineering data before the telemetry modulation unit sends it back to Earth. Without the FDS working correctly, all the information from Voyager's instruments was being lost, trapped in a corrupted digital loop. The probe was effectively sending us a dial tone instead of a conversation, a sign of life with no substance. It was a ghost in the machine, billions of miles from home. For the mission team, this was a moment of profound challenge. They were dealing with technology designed in the 1970s. The probe has less memory than the key fob for your car. Its schematics are on paper, its programming language ancient. The original engineers who built it have long since retired or passed away. A new generation of cosmic detectives had to piece together clues from another time to solve a problem in a place no one has ever been. They were performing remote brain surgery on a patient 15 billion miles away, using 46-year-old medical charts. The odds were long, the silence was deep, and the cosmic ocean felt vaster and emptier than ever before. To understand the heartbreak of Voyager's silence, you have to understand its incredible story. It begins in the 1970s, with a once-in-a-lifetime opportunity, a rare alignment of the outer planets, one that only happens every 176 years was approaching. This cosmic syzygy would allow a spacecraft to use the gravity of one planet to slingshot itself toward the next. Jupiter would fling it to Saturn, Saturn to Uranus, Uranus to Neptune. A grand tour of the outer solar system was possible. NASA seized the moment, designing two of the most ambitious explorers ever conceived, Voyager 1 and Voyager 2. Their primary mission was to visit Jupiter and Saturn, but their destiny was always aimed at the stars. Launched in 1977, just weeks after its twin, Voyager 1 embarked on a journey that would redefine our cosmic neighborhood. The probes were time capsules. Bolted to the side of each is a golden record, a gold-plated copper phonograph disc. It contains sounds and images selected to portray the diversity of life and culture on Earth. There are greetings in 55 languages, the music of Bach and Chuck Berry, and the brainwaves of a young woman in love. It was a message in a bottle thrown into the cosmic ocean, a greeting card for any civilization that might one day find it. The grand tour was the mission, but the ultimate goal was to see what lay beyond, to keep going until the light of our sun was just another star in the sky. The planetary encounters were spectacular, a cascade of discoveries that filled textbooks. Voyager showed us the churning, violent storms of Jupiter's Great Red Spot. It revealed active volcanoes on Jupiter's moon Io, the first ever seen beyond Earth. At Saturn, it unveiled the intricate, complex structure of its magnificent rings, finding they were composed of thousands of individual ringlets. It flew past the hazy orange moon Titan, giving us our first glimpse beneath its thick, nitrogen-rich atmosphere. Each flyby was a triumph, painting a new, more dynamic picture of the outer planets than we had ever dared to imagine. The mission was already a wild success, but its greatest journey was just beginning. After its stunning encounter with Saturn in 1980, Voyager 1's path was deliberately bent. It was sent hurtling up, out of the ecliptic plane where the planets orbit. This trajectory sacrificed a visit to Uranus and Neptune, leaving that to Voyager 2, but it put Voyager 1 on the fastest possible path out of the solar system. Its grand tour was over. Its interstellar mission had begun. For decades it sailed silently onward, its instruments measuring the fading influence of our sun and the growing presence of the vast, empty space between the stars. It was our scout, our sentinel, sent ahead to report on the nature of the cosmic frontier. What is the edge of the solar system? Before Voyager, we thought of it as a simple, placid boundary, a place where the sun's influence gently faded away. We imagined a bubble, the heliosphere, created by the solar wind, a stream of charged particles flowing outward from the sun. Outside this bubble lay interstellar space, the realm of other stars. We expected the transition to be smooth, like wading from the shallows into the deep. Voyager 1 and its twin, Voyager 2, showed us that the boundary is not a calm shore. It's a churning, chaotic, and utterly bizarre place, a cosmic tempest that defied all our predictions. The edge of our solar system is far stranger than we ever knew. The first hint of this strangeness came as Voyager 1 approached the heliopause, the theoretical outer limit of the heliosphere. This is the point where the solar wind is no longer strong enough to push back the stellar winds from the rest of the galaxy. Instead of a smooth decline in solar particles and a gradual increase in galactic cosmic rays, Voyager found a turbulent, frothy region. It discovered a magnetic highway, a zone where the sun's magnetic field lines connected with the interstellar magnetic field, allowing particles from inside and outside to zip back and forth. It was as if our solar system had opened temporary doors to the galaxy, creating a dynamic and fizzing frontier. Then, in August 2012, it happened. Voyager 1 detected a sudden, dramatic drop in solar particles and a simultaneous, massive spike in high-energy galactic cosmic rays. The data was clear and unambiguous. After a 35-year journey, Voyager 1 had punched through the heliosphere and entered interstellar space. It was the first object made by humanity to do so. It was now swimming in the medium between the stars, a place filled with the remnants of ancient supernovas and the raw material for new suns. It was directly sampling the galaxy, tasting the cosmic wind that blows between the stars. This was a monumental achievement, a moment that forever changed our place in the universe. But even in interstellar space, the surprises kept coming. We expected the magnetic field to change direction once Voyager 1 crossed the boundary. After all, it was now in a new region of space, governed by the galaxy's magnetic field, not our sun's. But it didn't. The magnetic field remained stubbornly aligned with the sun's. It was stronger and more compressed, but its orientation was the same. It was as if our sun's influence was clinging to the spacecraft, refusing to let go. This discovery sent theorists scrambling. The edge of the solar system wasn't a simple bubble. It was a complex, porous, and magnetically weird interface that we still don't fully understand. Back in the winter of 2023, the Voyager team faced their greatest challenge yet. Their most distant explorer was alive but mute, its scientific voice silenced by a glitch in its 46-year-old computer. The team, a dedicated group of engineers at NASA's Jet Propulsion Laboratory, refused to give up. They began a painstaking process of long-distance forensics. They knew the problem was in the Flight Data Subsystem, or FDS, but the FDS has 3 computers. Which one was failing? And, how could they fix it from 15 billion miles away? They couldn't just reboot it. A command that simple could have unforeseen catastrophic consequences for the aging spacecraft. They had to be clever. They had to be patient. Their first big clue came from a clever command they sent to the probe. They asked the FDS to try reading out its memory in different sequences, hoping a small change might bypass the corrupted section. In March 2024, after months of sending commands and waiting 45 hours for each reply, a signal came back that was different. It wasn't science data, but it wasn't the old gibberish either. It was a complete readout of the FDS memory. Buried inside that data dump, the team found the smoking gun, a single chip responsible for storing a portion of the FDS memory, including the computer's software code, had failed. It was likely fried by a high-energy particle from the galaxy, a cosmic ray bullet. This discovery was both good news and bad news. They had found the problem, a single tiny broken component, but they couldn't physically replace it. The solution had to be one of pure ingenuity. The team devised a daring plan. They would surgically slice up the affected software code. They would then beam the pieces, one by one, into different locations in the FDS memory, tucking them into nooks and crannies that were still working. Finally, they would update the main program to look for the code in these new locations instead of the broken one. It was like taking a book with a damaged chapter, reprinting that chapter on scattered blank pages throughout the book, and then rewriting the table of contents to point to the new pages. On April 18, 2024, the team began this delicate, high-stakes surgery. They sent the first part of the patch, the code related to the engineering data, to Voyager 1. Then came the agonizing 45-hour wait. On April 20th, a signal returned. For the first time in 5 months, it contained clear, usable data about the health and status of the spacecraft. It worked. The patient had stabilized. The team at JPL had successfully reprogrammed a computer across an interstellar distance, using their deep knowledge of a system they could never touch. It was a triumph of human persistence and intellect, a testament to the bond between creator and creation across the vastness of space. But the science data was still missing. The most important part of the conversation was yet to be restored. The success of restoring Voyager 1's engineering data was a moment of profound relief, but the job was not done. The probe's entire purpose for being in interstellar space was to send back science data, to measure the density of the plasma, the strength of the magnetic field, and the intensity of cosmic rays. On May 19, 2024, after carefully relocating the rest of the corrupted software, the team received the signal they had been fighting for. Coherent, beautiful data from 2 of the 4 science instruments flowed back to Earth. A few weeks later, all 4 were back online. The long silence was finally, truly over. Voyager 1 was speaking to us again, its voice clear and full of wonder. What did that first mysterious signal reveal after its long silence? It told a story of its environment. It whispered of the density of the plasma sea it was swimming through, the tenuous gas that fills the void between stars. It described the galactic cosmic rays that have been bombarding it, the same kind of particle that likely caused its memory failure. The data was a confirmation that the interstellar medium is not empty. It is a dynamic place, humming with energy and particles from distant, long-dead stars. Restoring contact wasn't just about fixing a machine. It was about reopening our only window into this alien realm. It was like suddenly being able to hear again after months of deafness. The return of this data is a gift. Voyager 1 is exploring a region of space we know almost nothing about. Every packet of information is a revelation, adding a new brushstroke to our picture of the galaxy. It is measuring the pressure and speed of the interstellar wind, helping us understand how our solar bubble interacts with its galactic surroundings. These measurements are crucial for understanding the environment that all solar systems exist within. Voyager 1 is not just on a journey for us. It is on a journey for any species that looks up at the sky and wonders what lies beyond its own sun. Its continued function is a scientific miracle, pushing the limits of what we thought was possible. The story of Voyager 1's silence and rebirth is a profoundly human one. It's a story about refusing to let go, about our deep-seated need to explore and understand. A team of people on a small blue planet reached across billions of miles of empty space to repair a machine they launched before many of them were born. They did it not for profit or power, but for knowledge. As Voyager 1 continues its eternal journey, moving at over 38,000 miles per hour, it carries more than just scientific instruments and a golden record. It carries our spirit. It carries our curiosity. And in its faint, resurrected whisper, we hear the echo of our own relentless desire to touch the cosmos.